Well, welcome to this online revision session for AQA FP3, in which we'll be looking at the June 2010 question 7 on solving differential equations. On this particular equation that we're going to be looking at is a second order differential equation, and in part B you can see we're going to end up solving it firstly by using an appropriate substitution to reduce it to an equation in terms of y and t, and then finding the general solution to that particular equation and then substituting back to solve the original problem involving y and x. And to help us do that, in the first part there are a couple of algebraic bits of differentiation which we need to complete. So if we look at these first parts, firstly we're asked to find dy by dx in terms of y and t, given that x is equal to t to the half. Well, we know that if x is equal to t to the half, then we could rewrite that as t equals x squared, and then from that we can write down the fact that dt by dx is equal to 2x, or alternatively, since x is equal to t to the half, we could write that as 2t to the half. Now how does that help us? Well, in part 1 we want dy by dx, and using the chain rule we can split that up into dy by dt times dt by dx, and of course dt by dx we've just found as 2t to the half, so substituting that in gives us the result that of 2t to the half times dy by dt. So that's the first part successfully completed. Second part, now we want the second differential. We're requiring d2y by dx squared. So again we can use the first differential above and the chain rule and say that this is going to be the same as the differential of dy by dx with respect to t, so we can differentiate the 2t to the half dy by dt with respect to t, and then multiply again by dt by dx. So we've used the chain rule on dy by dx by splitting it up into the differential of that with respect to dt times dt by dx. Now we can use the product rule to work out this first part. So the differential of 2t to the half becomes a half t to the negative a half, which just becomes t to the negative a half because of the multiplying by 2, times dy by dt, and then we leave that first part alone and we multiply and we differentiate dy by dt with respect to t, which gives us the second differential with respect to t. And then all of that has got to be multiplied by dt by dx, which we know is 2t to the half. And so multiplying through by 2t to the half, you can see what we're going to get. Well, the 2t to the half times that 2t to the half gives you 4t times that second differential, which is what we required. and then the 2t to the half times the minus 2t to the half will give us just 1, so that becomes plus 2 lots of dy by dt. Okay, well there's 5 marks for doing this part of the question. So for using the chain rule in the first part, you will get 1 mark, and then working through to the correct solution will give you an accuracy mark of 1. And again in the second part, for differentiating with respect to t and multiplying by dt by dx, will give you a mark. For then using the product rule to do that differential will give you a mark, and then finally for coming up with the correct result from there you'll get an accuracy mark in there for your total of 5 marks. Okay, so in the next part of the question we then got to use the substitution x equals t to the half to transform this second order differential equation with y and x into y and t. Bearing in mind we have these 2 results from the first part to help us, so immediately we can substitute in for by dx squared, and we can substitute in for dy by dx, and we can substitute in for x. So if we do that substitution, what are we going to get? Well, we're going to get x, well that's t to the half, multiplied by, well instead of the d2y by dx squared, we're going to write in here 4t d2y by dt squared plus twice dy by dt, and then we are going to have minus 8. Well, in place of the x squared we're going to put t to the half squared, so that becomes 8t plus 1 multiplied by dy by dx, which is the 2t to the half times dy by dt, and then we're going to have plus 12, and in place of x again it's t to the half, so it's t to the half cubed, so that gives us t to the 3 over 2 times y, and then that will equal 12, and again that's t to the half to the power of 5, so that's t to the 5 over 2. Right, well we start now simplifying this. We can see t to the half times this first part will give us 4t to the 3 over 2 d2y by dt squared. Oops. And then we get a plus 2t to the half times that 2 dy by dt, but we can see here we got a minus 2t to the half dy by dt, so those two are going to cancel out, and all we're left with is the minus 8t times this, so that gives us minus 16t to the 3 over 2 times dy by dt. And then we got plus 12 t to the 3 over 2 times y equals 12 t to the 5 over 2. Well, we're nearly there, because now we can divide through by 4, and we can divide through by the t 3 to the 3 over 2, and that will leave us with d2y by dt squared. In this part we will just get minus 4 dy by dt, and then here we get plus 3y, and that will then equal, well, 4 into 12 gives us another 3, and this time the t to the 5 over 2 minus divided by t to the 3 over 2, subtracting the powers, you get t to the 2 over 2, or just t, which is the required result. Just 2 marks here, obviously for the substitution, showing the appropriate method. We'll give you 1 mark, and then for carefully reducing it down to the correct solution, we'll give you the 2nd mark. And finally, on to the main part of the question. Using what we've now got, we should be able to solve this differential equation of y and x by using the y and t. So with this equation, we can write down the auxiliary equation for the y and t. So from that auxiliary equation, we got a single d2y by dx squared, so that gives us just a single m squared. We then got minus 4 lots of m from the dy by dt plus 3. So those are your coefficients of each of these terms, and that will equal 0. And from that we can factorise it quite quickly into m minus 3 and m minus 1 equals 0. So that tells us the values of m as being 3 and 1. So we immediately know in this case the complementary function for y in terms of t as being y equals a e to the t plus b e to the 3t. Then we need a particular integral. So to find a particular integral, we need to try, well, what have we got over here? It's got 3t, so remember that means we would try a particular integral which is a multiple of t, say little at plus some constant b. And then to find the values of a and b, we substitute them back into that 2nd order differential equation. So we know that dy by dt will be equal to a, and the 2nd differential would be 0. So when we substitute them in, we're going to get minus 4 times dy by dt, so that's a, plus 3 lots of at plus b must equal 3t. So comparing the coefficients of t, we got 3at on the left and 3t on the right, so that tells us that a must equal 1. And then comparing the other constants, we got 3b and minus 4a, so if a is 1, that will be telling us that b will have to be 4 over 3. So that gives us our particular integral, as y equals t plus 4 over 3. So to get our general solution from that, we know it's going to be of the form y equals our complementary function a e to the t plus b e to the 3t plus at plus b. So a is 1, so that becomes plus t plus b, which is 4/3. So that is the solution to our 2nd order differential equation relating y to t. We wanted the solution relating y to x. So now to finish the problem off, we got to substitute back in for t, well, we know that t is equal to x squared if x is equal to t to the half. So substituting that in gives us our general solution as a e to the x squared plus b e to the 3x squared plus t, well, t is x squared, plus the 4/3. Well, where do we get the marks? There's 7 marks in this particular case. Well, for achieving or obtaining the values of m by using the auxiliary equation, you will get 1 a method mark, 2 an accuracy mark for writing down the values of m, and then for writing the complementary function you will get a mark. Trying your particular integral as at plus b or something of that form will give you a mark, and then obtaining the correct values for a and b gives you a mark, and then stating from that what the general solution is for the differential equation of y relating y to t will get you a mark, and then finally substituting back for t in terms of x squared and writing down the correct general solution for the originally second order differential equation gives you your final mark to give you your 7 in total. Well, hopefully you found that solution helpful. For more solutions and help with your revision, please go to the Further Maths Support Programme website.